This is a mini lesson as a reminder of how to graph quadratic functions. We have our function here, y equals negative x squared plus 2x plus 5. Remember, since this is a quadratic function, it's going to be in the shape of a parabola. We also know that this is going to open downward because of our negative right there on the a. So that also means our vertex is going to be a maximum point, which we'll look at here in a minute. The first thing we need to do, remember, is find out where our axis of symmetry is. The equation for that being x equals negative b over 2a. The a in our function is negative 1. B is 2. The c, which we'll use when we're graphing, is 5. So now we can take a and b from here, plug them into there. Remember to always write that negative right there, and then plug in your b. So I have negative 2 over 2 times whatever my a is, in this case negative 1. Now we need to multiply this and simplify. Negative 2 over negative 2 becomes positive 1. So this is the axis of symmetry now. It's going to go through the middle of my parabola, and it's going to go through the vertex. The line x equals 1 goes right through here. So we'll imagine that going that way. Now that we have an x, we need to get the y for our axis of symmetry, or for our vertex, excuse me. Take the 1 that you have there already, and we're going to plug it in for x there and x there. Y equals negative 1 squared plus 2 times 1 plus 5. 1 squared is 1, so we have negative 1 plus 2 plus 5. When we add this all together, that first part gives us 1 plus 5 equals 6. That's the y of our vertex. So the coordinates of our vertex then, taking the 1 from here, the x, and the y right here that you plugged in, is 1, 6. Let's graph that. To graph the point 1, 6, here's my x of 1. We got that already. Now let's count up 6 for y. 1, 2, 3, 4, 5, 6. And we can put a point right there. We also have another point that we can put in right now. We looked at the y-intercept of our function is right here. It's always the c. So I can put the y-intercept also at 5. Now we need some more points to finish out our curve. My tip for picking the x values to fill out the curve is I just pick the next x's over. We started our axis of symmetry at x equals 1. The next x over would be 2. So let's get a point at x equals 2. And we'll plug it into our function. Y equals negative 2, because that's where we're looking at, squared, plus 2 times 2 plus 5. 2 squared is 4. Stick the negative on there, plus 4 plus 5 comes out to y equals 5, which gives us a new point to 5. Which happens to be right there. I hope now you also notice that because this is the axis of symmetry, that the y value over here should be 1 spot away from the y-axis of symmetry as the y value over here, that y-intercept we already plotted. So those are both 1 away from the axis of symmetry, and they're both 5. So there was some proof that you did your y-intercept correct. Let's pick our next x over, which would be x equals 3, and plug that in. Y equals negative 3 squared plus 2 times 3 plus 5. 3 squared is 9, keep your negative, plus 6 plus 5. That comes out to y equals 2. Next point on our quadratic function here then is 3 that we plugged in and 2 that we just evaluated. We can plot that. 1, 2, 3 on the x's. 1, 2 up. This is where we pick our reflection point. At x equals 3, we're 2 away from the axis of symmetry. Let's go 2 this way and stay at y equals 2, excuse me. Okay, we've got points. We're set to make our curve now. Parabola looks like a U. So you'll do your best to go through all those points. Make a U and remember to put your arrows.